Hello, good morning, and Happy New Year, sir. So this is my video about electron transport chain. So to start with, what is electron transport chain? Electron transport chain is a series of four complexes that couple the reduction and oxidation reaction, creating electrochemical gradient that leads to the creation of ATP. So the main goal or main purpose of the electron transport chain is to create more ATPs. So this electron transport chain is happening in the inner mitochondrial membrane of the mitochondria. So the mitochondria has two membranes, which the outer and inner mitochondrial membrane. In the space between the inner and outer mitochondrial membrane is what we call inner membrane space. Then the space inside the inner mitochondrial membrane is what we call mitochondrial matrix. So in the inner mitochondrial membrane, this is where the electron transport happen. Then it has four complexes. Four complexes: the complex 1, 2, 3, and 4. The complex 1 is also, we can call also the complex 1 as NADH dehydrogenase complex, and the complex 2 is the succinate dehydrogenase, and the complex 3 is the cytochrome reductase, and the complex 4 is the cytochrome oxidase. So from the Krebs cycle, we generate 6 NADH and 1 FADH2. So these two molecules is very important for these two molecules is the one will be in use for the electron transport chain, because they're the one who carry the nitrate that has one proton and two electrons. So the NADH in the complex 1, this is where the NADH being oxidized. So when we say oxidation, it is removing of hydrogen, or yeah, it is removing of hydrogen. So from NADH the complex 1 will remove the hydrogen from the electron from NADH. So NADH now will become a NAD plus. So now the complex 1 or NADH dehydrogenase complex is contain the electron. Then the electron will be passed to this mobile enzyme that what we call is coenzyme Q. This is a mobile enzyme, and it's not built it's not built by protein. So during the transfer of electron from complex 1 to coenzyme Q, the complex 1 what do you call this? Remove proton from release proton from the matrix to the inner membrane space. So during the during the transfer of electron from complex 1 to coenzyme Q, it really the complex 1 release proton from matrix to the intermembrane space. So from coenzyme Q, the electron from coenzyme Q will be passed to complex 3. So before we proceed that, let's talk about the complex 2 first. So the complex 2, which is the succinate dehydrogenase, is the same enzyme that catalyzes the the molecule succinate in the Krebs cycle and become fumarate. I think that's a fumarate. So it's the same enzyme. So from FADH, it oxidates from complex 2, it's oxidates the FADH and become FADH2 and become FAD. So the complex 2 will the one who oxidize the FADH2, and the complex 1 is the one who oxidize the NADH. So same thing, the from complex to the enzyme that will it will transfer from complex to it will transfer the electron to coenzyme Q also, and coenzyme Q will transfer the electron to complex 3. But the difference between complex 1 and complex 2, aside from only NADH that oxidize the only NADH being oxidized and complex 1 and FADH2 is oxidized and complex 2. The different also the other different thing is the complex 2 has no channel to release proton. There's no hole to complex 2 has no hole to release proton from matrix to the intermembrane. So the proton from FADH2 will remain in the matrix. So from coenzyme Q, so the electron is now in the coenzyme Q from NADH, from complex 1 and complex 2 na is in the coenzyme Q. Then the coenzyme Q will transfer, since it's mobile, it can move and transfer the electron to complex 3, which we call cytochrome reductase. So cytochrome being now the complex 3 is being energized, having the electron. So by that, it also has a channel to release proton by during transferring the electron from complex 1 to cytochrome C. It complex 3 release proton also to the intermembrane space. So the electron is in the cytochrome C. It's also a mobile molecule that can move, and it's not also built by protein. So from cytochrome C, it will transfer now the electron to complex 4 or cytochrome oxidase. This is where this is the last complex where the last complex and receive this the fourth complex. It will receive the electron, and also then after that complex 4 will transfer the electron to the oxygen, because there is available oxygen within the available oxygen within the matrix. Half of oxygen will get the electron, and combine with the 2 hydrogen, it produce water. By the way, also the complex 4 also has a channel that can release proton, can release proton from any mitochondrial matrix to the inner membrane space. So as you notice, complex 1, complex 3, and complex 4 are as capable to has what you call this, a channel. They release proton from matrix to the intermembrane space. So by that, there will be a high concentration there will be a high concentration or number of protons in the intermembrane space. Yes, then how's that? To maintain the balance, the proton from intermembrane space will need to go inside the matrix, which is where is the lower concentration, since only lesser proton inside the matrix. So they will go in the matrix by means of the ATP synthase. Then by that, during entering of proton to the mitochondrial matrix by means of ATP synthase, it create chemical force that makes the available ADP and phosphate inside the matrix to combine and produce ATP. So this process is what we call chemiosmosis. By by producing by combining ADP and phosphate to become ATP. By producing ATP is what we call chemiosmosis. So that's how the ATP produced during electron transport chain. So what else? So by the combination, the electron transport chain is only from the electron transport chain process is only from the transfer of electron from complex 1 to complex 4, but the making of ATP synthase, that what we call oxidation process from complex 1 to complex 4. Then from the what's this making ATP, by combining ADP and phosphate available in the matrix, is what we call phosphorylation. Then combining the two process is what we call oxidative phosphorylation. So that's all my understanding about electron transport chain, sir. Thank you. Have a good day.